Hello, welcome back to SCI Teach. This is a titration practical between hydrochloric acid and sodium bicarbonate. So it's important to note that hydrochloric acid is a strong acid, while sodium bicarbonate, or we call it sodium hydrogen carbonate, is a weak base. So when we titrate a strong acid against a weak base, then methyl orange is the best option to use as indicator. Okay, that's because methyl orange operates and works well around pH of 3.1 to 4.4. Why we can't use phenolphthalein is because of the weakness of the base, sodium bicarbonate, and also the fact that phenolphthalein changes color in a pH range of 8.2 to 10.0. That's well above the pH of the neutralization of sodium bicarbonate and HCl. So in this titration, we're going to use methyl orange as indicator for precision. Also, when a strong acid is titrated against a weak base, the solution will be slightly acidic at the end point. Okay, so if it was a weak acid titrated against a strong base, the solution will be slightly basic because the salt that will be formed will be hydrolyzed to some certain extent. So in this case, we are using a strong acid, hydrochloric acid, against a weak base, sodium bicarbonate. So the end point will be a little bit acidic. So that's normal. Alright? It's important to note that the neutralization reaction, the titration between sodium bicarbonate and hydrochloric acid will yield sodium chloride, salt, water, and carbon dioxide. Okay? So expect questions about the gas evolved, carbon dioxide. Remember to subscribe to this channel, like and share the videos to your friends who are students, so that as we are preparing, they are preparing also. Okay? Let's get into it. And we're going to use a sample question, a Waec sample question. And you may see it like this in your exam hall. But whatever you will see would dance to this tune. Okay? The values may change, but the structure will look like this. Let's go. D is 0.095 molar dm cube HCl. Yours can be D is 0.1 molar dm cube HCl. Could also be that it's not D, it is A. And then E is a solution prepared by diluting 10 cm cube of a saturated solution of sodium bicarbonate at 25 degrees Celsius to 1000 cm cube with distilled water. The one case could be 15 cm cube, could be 8 grams, whatever it is. Those information does not concern you for the titration. The people preparing the solution uses that to prepare, but it may concern you in some certain parts of the calculation when you're asked to calculate the mass of the salts, mass of the sodium carbonate and all that. But for this titration, it shouldn't concern you right now. So you're asked to put D into the burette and titrate it against 20 cm cube or 25 cm cube portion of E. So D is the acid, D is the HCl, and E is the sodium bicarbonate. So they're asking you put the acid into the burette and then titrate it against 20 or 25 cm cube of E using methyl orange as indicator. So the pipettes you have could be 20 cm cube. It could also be 25 cm cube. We have two standard volumes for pipettes. It could be 20 cm cube or 25 cm cube. The one you are given to use is what you will use. If the one you are given is 20 cm cube, then that's what you are using. But if it's 25 cm cube, that's what you are using. But when you do the calculations, you see have the same answer. Okay, so we are going to put D, which is our acid A, into the burette, and then we titrate it against. I'm going to use 25 cm cube to measure my E, which is my base, and I will use methyl orange as the indicator. Let's go there. So is the process. You see, what I'm calling A is the D in the equation, okay, because I'm calling this my acid and this is hydrochloric acid. All right, so don't confuse yourself. All right, then this is my sodium bicarbonate, so I'll dissolve this according to the standard measure and then use it as my B. Okay, so I have my distilled water and I have my acid where I reduced the A from. All right, so the next thing is to fill in the burette. That's put A, which is in the equation, put D, so let's call it D. I'm putting D into the burette right now. Okay, my burette is standard burette, so it's measured from 50 to 0 from top and 50 down there. So I'll fill it up. You can see I'm filling the D, which is HCl, into the burette. Alright, so if it passes the 0 mark, no problem, you can drop back the beaker and reduce the content into it. Make sure that the meniscus sits on the 0 line. Okay, so do it very carefully to make sure that it doesn't pass the line. Go. Okay, so it doesn't sit. We have to carefully make it sit, and it sits. All right, so that means that is 50 cm cube of A filled into that burette, of D, of the acid HCl filled into the burette. Okay, now the next thing I will do is to pipette my 25 cm cube of B, okay, the E in the equation. Don't be confused. A is the acid, B is the base for me. Okay, so that's 25 cm cube of sodium bicarbonate measured and then turned into the conical flask. All right, so the conical flask is where you turn your base into. And after you do that, remember we're using methyl orange, so it depends on the concentration. Mine is very thick, so 1 or 2 drops should be enough. So if I drop 1 and it's dark enough, okay, that should do. So I've put in my methyl orange, which will enable me know the end point. The end point is the point where you see the slightest color change. When it's no more orange color like this, then that is your end point. So observe this color at the start now, so that you'll be able to differentiate the end point. So you see it's orange now, and I'm titrating, dropping the acid into the base slowly. Depending on the concentration of the acid, this could have been, the end point would have been reached by now if the acid concentration was high, but it's not that high, so demands or needs a lot of the volume of acid has to be more than it would be if it was more concentrated for me to be able to reach the endpoint. So you keep dropping with patience and swirling. Keep swirling so that when it drops, it mixes in. So you won't be confused that it has reached the endpoint when you see the pink color inside. So you swirl. I can't call it shake because it's not shaking, right? This is swirling. You can see at the middle you see pink coloration, but when you swirl, it's okay. We are reaching the endpoint. Okay, that is our endpoint. That's our endpoint. So that should be the end of this titration. Now I left this tap loose. That is what you must not do, because if it keeps dropping in like this, it keeps adding the acid to the supposed neutral solution. So you see, since the tap is loose, it keeps dropping. So it's either you lock it, if the stopper is not working properly, then it's better you remove the conical flask once the endpoint is reached. Okay, just remove it. So if you keep adding and the color turns pink, okay, let's add more so you see how the color can become too pink, and this is not a neutral solution anymore. This is maybe this is an acid. If you put in your what do I call it? If you put in your litmus paper, it will show that it is an acid. So avoid dropping it too much. Once your endpoint is reached, please, if the stopper is not working, remove the conical flask. All right, so you can then go ahead and take your measurements. What's the volume of the acid in the burette that has been used up, and then you record that, you rough and repeat the process for 2 more times to have consistent titer to find the average. All right, so let's get back to our question. So the question said to put the acid into the burette and titrate it against 25 cm³ of the base using methyl orange as indicator. We've done that. We have to repeat that same process to obtain consistent titers, and then tabulate the readings, the burette reading, and calculate the average volume of the acid used. Remember, the equation for the reaction is NaHCO3 sodium bicarbonate plus HCl aqueous, potable aqueous, that's in solution, hydrochloric acid, yields sodium chloride aqueous plus carbon dioxide gas plus water liquid. So there is carbon dioxide gas evolved. So normally, if you do all this correctly, your 10 marks is already set. All right. Now, B says, from your results and the information provided, calculate the I, concentration of E in mole dm³. II, solubility of sodium bicarbonate. That carries 5 marks, the B. And then the C says, states the effect of the gas released during the reaction on damp litmus papers. Then also state one chemical test to confirm the gas released. And also you have to name one chemical industry that uses this gas as one of its raw materials. And also list 2 or other processes that can release this gas into the atmosphere. So we'll start from B. Okay, we should calculate the concentration of the E of the base, sodium bicarbonate, in mole dm³. All right, now we already know that we have a Carver formula, so to say. CAVA all over CBVB equals to NA all over NB. So if the question is giving you like this question, it didn't call it A and B, it called it D and E. So CAVA becomes CDVD all over CBVB becomes CEVE, because D and E is what you were using, equal to ND all over NE. Okay, so CD is concentration of the acid, that's Ca. VD is the volume of the acid. Okay, CE is the concentration of the base, which is what we are asked to find, and VE is the volume of the base. If you look at the equation, it was 1 mole of sodium bicarbonate reacting with 1 mole of hydrochloric acid. So number of mole of acid to that of base is 1:1. So Na, or that's ND, is 1 and Ne is 1, so equals to 1 over 1. So we make Ce, concentration of the base, subject of equation because that's what we are asked to find. Ce will be equals to CD VD all over VE. Since it was 1:1, 1 over 1 to cancel out, so we don't need that. So we substitute our values. Concentration of the acid was 0.095 from the equation, and then the volume of the acid is what we find. You find in your average, okay, your average titer that you did first time, second time, third time, and then use maybe the last two to find the average. Okay, when you do that, that is your volume of acid, that's VD. You put the value there, all over VE, volume of the base. Remember, you could have used 20 cm cube or 25 cm cube. To me, I used 25, so VE will be 25 cm cube. So whatever you used, key in those things. Okay, if your volume of acid from your average, because it's going to be different and concentration is different from the one you will use, but whatever you use, when you calculate your average, put that average where you are finding VD, that's your VA. Okay, and then the volume of the base depends on the pipette you used. If you use 20 cm cube pipette, then you are writing under where VE is 20 cm cube. If you use 25 cm cube, you put 25 cm cube, and then you calculate the 0.095. If it was 0.095, your own could be 0.1. Whatever it is times whatever volume of acid is all over whatever volume of base is, will give you your concentration of the base in mole dm cube. Okay, now BII asked us to calculate the solubility of sodium bicarbonate. Now you can't do that if you don't know what dilution factor is. Okay, so dilution factor is sort of the number of times something is diluted. Okay, so if you look at the equation said that 10 cm cube of E, and E is NaOH, was diluted. 10 cm cube was diluted. So what is the dilution factor? Understand that dilution factor depends on how much you dilute that substance. So it's not a fixed value. It should be calculated. In this question now, 10 cm cube of the sodium bicarbonate was diluted. And dilution factor, the formula is final volume all over initial volume. Okay, so if you dilute something standardly, that means you put that thing in 1 liter of water. That's 1 dm cube of water. That is 1000 cm cube of water. Since the equation says that 10 cm cube of that sodium bicarbonate was diluted, that means it was diluted in 1000 cm cube of water. That's standard. So since it was 10 cm cube of NaOH in 1000 cm cube of water, that is 10:1000. Okay, so the dilution factor then would mean that dilution factor is 10:1000. Okay, and you can bring that down to a simpler, or the simplest term. 10:1000 is the same as saying 1:100. So the dilution factor of E is 1:100. So that means to find the solubility, you just say the concentration of that base that you just found in mole DM cube times this dilution factor of 100 will give you the solubility. That is 100 times the value you had for concentration of the base in mole DM cube. Okay, so if that concentration was 300 times 3 would mean 300 is the solubility of NaHCO3. Okay, that's the simplest way to solve it. So if you solve it that way, we've had our 5 marks for B. So 10 marks for doing that titration correctly, and 5 marks for answering concentration of base and solubility of the base. 15 marks already bagged. Then C says, states the effect of the gas released during the reaction on damp litmus paper. And I told you already that carbon dioxide gas was released. You saw it in the equation. So that's where the test for carbon dioxide gas comes in. You know, the most important test is test with lime water, calcium hydroxide. That carbon dioxide turns lime water milky. So in your specimen you would see lime water. All right. So we are going to state the effect of the gas as carbon dioxide released during the reaction on damp litmus paper by first of all using the damp litmus papers. So it was not stated if it's blue or red, so you use both of them. You pick the blue litmus paper while you are doing the reaction. You bring a damp litmus paper. How you damp it is just bring a litmus paper and then sprinkle a little water on it. Don't go and wet it so that you cut. Just sprinkle a little water on it to make it moist. Okay, and then use it over the gas. As the gas is coming, let it touch it. You will see that the blue litmus paper will turn to red or pink if you want. Okay, now carry the red litmus paper, another one, a red litmus paper. Do the same thing, moist it, and then put it over the gas as it's coming out, and you discover that it won't change any color. So that would mean that it doesn't have any effect on red litmus paper. So you report it. You write it as your CI. You state that damp blue litmus paper turns red or pink, and also that there is no effect on damp red litmus paper. And then CII says, state one chemical test to confirm the gas released. That's where you talk about lime water test. Okay, so you state that the gas, when passed into lime water, turns milky. If you like, you write lime water test and you write colon and say if you pass the gas into lime water, the lime water will change from colorless to milky color. Same thing, but you've reported CI and II, and you've gained 4 marks. So that's like 19 marks if you answer all this correctly. And then you go to D. D says, name one chemical industry that uses this gas as one of its raw materials. Okay, and you know that we have, for instance, the food industry, the drinks industry. You know that carbonated drinks, aerated drinks, like your Coke, Pepsi, all those, they use carbon dioxide to give it that fizzy taste. Okay, so if, even in the manufacture of sodium carbonate, Na2CO3, in solver process, okay, those industries use, these chemical industries use the gas that was evolved, that's CO2. And then DII says list 2 other processes that can release the gas, that's CO2, into the atmosphere. So respiration, okay, when you breathe in your lungs take in a mixture of oxygen and carbon dioxide, but the blood take up the oxygen and the carbon dioxide is released back into the atmosphere. So respiration helps or also releases carbon dioxide into the atmosphere. Burning of fossil fuel, okay, combustion of hydrocarbons will release carbon dioxide into the air, and carbon dioxide is a greenhouse gas, so that's why you are told don't burn in open air, burn in incinerators, because if you burn, whether it's cloth or firewood or whatever you're burning, it has carbon in it, and because it has carbon, it's going to release carbon dioxide gas. So burning of fossil fuel like wood, petrol, maybe kerosene, diesel, so in your exhaust pipes, your generator fumes, so that's most times carbon monoxide. But burning generally of fossil fuel and carbon materials will release carbon dioxide into the atmosphere. Also, decay of organic matter, okay, during decay, carbon dioxide gas is released with heat. And then in volcanic eruption, that's almost burning, okay, so it melts all those carbon compounds, and then the gas is released, carbon dioxide, into the atmosphere. And then fermentation of sugars also release carbon dioxide. So if you answer all this correctly, remember you're asked to mention just two. I've given you a lot of them. So if you named one chemical industry, maybe you just say food industry, or you say drinks industry, okay, and then you mention two other processes, maybe you mention respiration and burning of fuel, you already have your 3 marks. Okay, so you see how easy it can be for you to pass question 1 chemistry in Waec or NECO. Okay, so with that, you see 10 marks plus 5 marks, that's 15, plus 4, 19, plus 3 marks, 22 marks gotten with smiles. Easy peasy. But follow the instructions carefully. Make your calculations carefully. Avoid errors due to parallax reading. Don't, when you set up your burette, you pour in the acid into the burette, it doesn't even land, the meniscus will not even sit on the 0 line, and then you start titration, but you record 0. That's error. It wasn't 0. And then, or maybe it's even above it, or it's hanging on it. Or when you are taking measurements after the titration, you just keep adding some 0.1s or from 1 and stuff like that. It will give you errors that will lead to you not having the correct range of endpoints or average titer. Okay, so make sure the meniscus or wherever you are taking readings from is on your eye level. Don't look at it from under, don't look at it from above. Let it be at your eye level. If it's too high, if the table is too high, you can bring it down on a stool that is lower, or you climb a stool so that you will see the level, the where you're going to take reading from, the level of the liquid inside the burette. You see it on your eye level without having to look up or look down. That's when you get your readings correctly. Okay, you do all that and do your calculations, recheck them to be sure you didn't make mistakes. Write your formulas before you substitute. So like you saw, I write my CAV all over CBVB equals to NA all over NB, and then made what I'm looking for subject and then substituted. If you don't write the formula, you will lose some marks. Okay, so write the formulas and do your conversions well. When you need to convert from CM cube to DM cube or whatever conversions, know the right conversions to make. And also understand that in this practical, a gas is released, and once a gas is released, expect the examiner to ask you questions about this gas that is released. So read up everything you need to know about carbon dioxide gas, everything you need to know about sodium bicarbonate as a weak base. okay, and know all this, and then you will be grounded on whatever question you will see in your exams. And then you finish doing that, make sure you write your name clearly, you write your exam number clearly, and all those except is printed for you. Okay, remember to subscribe to this channel, like and share the video to your friends and classmates who are writing exams too, or just wants to learn titration, especially with hydrochloric acid and sodium bicarbonate. So that's you're gaining good knowledge, they are gaining them also. Okay, thank you for watching. God bless you.